What's up, you freaking geniuses? So in this video, I'm going to teach you how to write quadratic functions in standard form when you're given the vertex. All right, so here it just says write a quadratic function in standard form whose graph satisfies the given conditions. All right, and it tells us that the vertex is right here at -3, 4. And just to remind you, standard form is this function right here. So it's f of x is equal to ax squared plus bx plus c, where a, b, and c are just numbers. They're just coefficients, okay? Now, since here it's giving us the vertex, we can actually use vertex form in order to write our function, all right? So if you don't remember, vertex form is this one right here. So it's f of x is equal to a times x minus h squared plus k, all right? Now, h and k over here are your x and y coordinates of your vertex, all right? The only different thing with the x-coordinate is you put the opposite sign, all right? So let me show you how we do that. So simplifying this, we're going to have f of x is equal to a. Now a is just a coefficient also. It can be any number you want, positive or negative, but I recommend plugging in a 1 for a, and that's because when you multiply 1 by all this crap over here, it's not going to change anything, right? Because when you multiply by 1, all this stuff just stays the same, okay? So we're going to use 1 for a. And then here, we're going to have x. And what are we going to plug in for our h? Well, we're going to use our x-coordinate over here, which is a -3, okay? But since our x-coordinate is a -3, you're actually going to put +3 right here, okay? And then this is squared. And then for our k value, it's a +4, but this one can stay +4, okay? So we're going to put +4 right there. Okay, so again, that was kind of the only tricky part of setting the problem up, right? So here we had a -3, so here you write it as +3. But, you know, the other way around, if we had a +3 over here, down here we would have written -3, okay? But your y value, it always stays the same. So if it's positive over here, it stays positive over here. If it's negative over here, it stays negative over here, okay? So then we're going to simplify this some more. So this is going to be equal to 1 times, now x plus 3 squared, we just need to multiply that out. So we're going to write that as x plus 3 times x plus 3. And then we have a +4 at the end. Okay, so here we have a binomial times a binomial, right? So in order to multiply binomials, all you need to remember is the FOIL method. And if you don't remember what the FOIL method is, I'll link a video to that in the card above. But this basically just stands for first, outer, inner, last, right? So that's the order you multiply the stuff in. So you're going to multiply first, and then outer, and then inner, and then last, okay? So then this is going to be equal to 1 times, and then just multiplying that all out, it's going to be x squared plus 3x plus 3x plus 9. And then we have +4 at the end. Okay, now combining like terms, we have a 3x and a 3x, so that's equal to 6x, right? So this is going to be equal to 1 times x squared plus 6x plus 9 plus 4. Okay, now we've had this 1 kind of just hanging out here in the front this whole time. So 1 times all this crap right here is still just equal to all this crap right here, right? Nothing changes when we multiply by 1. So then so 1 times this over here in parentheses is still just going to be equal to x squared plus 6x plus 9, right? And then we still have our +4 at the end, okay? And then combining like terms one more time, 9 plus 4 is equal to 13, all right? So then your final function over here, it's going to be f of x is equal to x squared plus 6x plus 13, right? There's your function in standard form. Boom. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.